Okay, guys, we're going to go into our next episode. And today we'll be discussing a follow-on from our last few episodes with division. In specific to today, we are looking at turning fractions into their decimal equivalents. So again, guys, what I've done is below I put for you guys the times table grid, and do reach out to me for any resources, and I will be happy to send over anything required. If you look over here, also on the other side, I've put the 8 times table there just to give you a better outline of how to do some of the questions if you're having difficulty with your times tables. Now, by putting the times table on the side, it does help out when it comes to not having to recalculate things in your mind, and it's there for you. Okay, so let's go straight into it. So in the case of making a fraction putting the fraction into the bus stop method, well, the first step is to get the numbers in the right place. So now what numbers go on the outside of the bus stop and what go on the inside? In this case, our denominator goes on the outside. So that, as you can see, is the number 8. And the number on the inside is your numerator, which is 5 in this case. All right, so let's go into it. So the first case is we see how many 8s go into, let's say how many 5s go into the number 8. In the 8 times table, we can clearly see that 8 times 1 is 8. Therefore, the number 5 does not appear. So in this case, we put a 0 there at the top. Now, as you've seen previously, when we finished and there's no more numbers left, we put a remainder on R and then put the number next to it. Well, in this case, we're making decimal equivalents. So therefore, what we do is we put a decimal point at the top and the bottom in line with each other. And then what happens is we put an automatic 0. Now that automatic 0, what happens is usually always after the decimal point, we are in a position where we have to put an automatic 0 by rule. And that goes along with our remainders, as you will see as I progress on. So we have the number 5. The number 5 has not been used, therefore 5 remains. So that 5 goes next to the 0. And that new number now becomes 50. So now what you're doing is you're getting the number 8 and you're saying, all right, I've got 50 there. How many 8s go into the number 50? So I'm going down my 8 times table and I can see that 48 and 56 are the closest. However, 56 is bigger than the number in question. So therefore we go to the number that's just smaller, which is 48. Now you're doing how many 8s go into 48? So you've got 8 times 1, 8 times 2, times 3, times 4, times 5, and times 6. So therefore we put 6 at the top. Now in your head, you should be doing this calculation where you get 50 is the number that you've got, and you're taking away the number that you've made, 48. So 50 take away 48, you should know gives you 2. Now again, because we've got another remainder here in 2, we put a 0 there, automatic 0, and put the 2 next to that. So now the number becomes 20. So how many is going to 20? Again, we're going down our times table list. So we've got 8, 16, 24. 24 is too big. So we settle with 16. And that is 2 times. Now, again, you're going back into your calculation, your mental calculation if need be, or if you're a bit stuck and you need to write it down, you're welcome to do so. 20 take away 16 gives you a remainder of 4. So that, again, we've got another remainder. So we put an automatic 0 and the remainder goes in front of it. You end up with a new number, which is 40. Now, if we go back to our times table grid, we can see that, yes, we've made 40 and there's no remainders after this. Therefore, this will be our last step. So 8 times 1, times 2, times 3, times 4, and times 5. So we end up with 5 there. That gives us a final answer of 0.625. Therefore, 5 over 8 is decimal equivalent is equal to 0.625. Now, guys, in just another thing to know is when you're in examination preparation for 11 plus SATs, GCSE, and so on and so forth, they will outline how many decimal points that they wish for you to stop at.